let's take a look at the next potential relationship. What kind of angles are angles 2 and 6? 2 and 6 are opposite sides of the transversal, both in the interior of the lines being intersected, so those are alternate interior angles. Okay, so let's see, is it true that if alternate interior angles are equal to each other, is that enough to show that the lines themselves are parallel? All right, so right now, the only way that we have to prove lines are parallel is SSI, the same side interior angles, are supplementary. Okay, so is there any way that we can introduce a pair of, or in order for that to occur, we need to wind up showing that a pair of same side interior angles here are supplementary. So we need an expression, two angles add up to 180, that needs to be introduced into our proof. And then we have to be able to relate either same side interior angles 2 and 3 equal to 180 or 6 and 7. It doesn't matter which one we choose. Okay, but let's try to introduce the elements from one of those. Okay, so what do we know about, again, we need to introduce either angle 3 or angle 7. Do we have a relationship involving either of those angles? So we look at this relationship here. What do we know about angles 3 and 6? They add up to 180 because they're what kind of angles? Definition of linear pair. Okay, so if we know that those are a linear pair, add up to 180, what can we do with this angle 6? It's equivalent to what? It's equivalent to angle 2. So if we replace that directly, replace angle 2 right in for angle 6, we get this new statement. Replacing is described in a formal proof as substitution. And so now what can we say about our two lines here? M and N are parallel, and the reason is what? SSI. We have same side interior angles 2 and 3 are now supplementary, therefore the lines have to be parallel to each other. So we just went through a second theorem involving parallel lines, or to prove parallel lines. And that theorem was if our alternate interior angles are equal, then that's enough to show that lines are parallel. Again, when we look at the anatomy of this theorem, the if part, the conditions, the then part is the resulting conclusion. And once again, we can abbreviate our theorem. Alternate interior angles can be used to abbreviate the relationship that if alternate interior angles are equal, then the lines themselves are parallel.